Hi folks, I'm Dr. Nick Bearman, and in this short video I'll take you through one of my practicals from my Advanced QGIS Spatial Analysis course. This practical is number 4, Practical 4, Spatial Overlays. So if you haven't done so already, make sure you do Practical 3 first. There's a link in the video below. So make sure you do that first, because we're going to pick straight up on this for Practical 4. So I just share my screen. So this is where we got to at the end of practical 3C. So we've got our green space access point data, the dots, and our LAD IMD pop count layer, the orange one here, with our various statistics in. So in this, we're going to do a polygon overlay. So we're going to take the green space site data polygons and overlay that with our local authority polygons. So first of all, we need to save this as a new project. So we're going to go project, save as, and we're going to call it practical 4. We're going to choose save. And we're going to add the green space site data. So this is what we downloaded from Ordnance Survey Open Data. So we used the access point already. We want the green space site data. So this is for the TQ area. And we're also going to do the same for the SU area. And so like before, it's always good to have a look at see what the data is that we've got. So we can put our point layers on top just so we can see how they relate. So let's have a look at this example. So here, Weimer's Wood, we've got this area which is green space, and then we've got an access point here. This is very typical. We've got a smaller one, something here. Farnham Common Sports Club. So that's a more kind of formal space. And here we've got some access points. So we've got 5 of those here. Cool. So I'll put the point data away. So we are also going to continue to use the data we're working with, but we want to make a copy of this. It's best practice to, if you're editing data, editing a copy. So we can copy our existing geo package and we can rename that to Practical 4 data. And then let's add our new geo package. So we can do this through the open source data manager window, or we can do this from here as well. So if we go right click, new connection, then point it at the geo package. So in this case, it's in GIS and then Prac4 data. We'll call this Practical 4 data. So I've got quite a few here, but Practical 4 is one we've just added, and these are all the layers that we've had so far. So these are the ones we're working on, and that's fine. We can add to these as we go through. So if you remember, we merged the green space point data. We need to do exactly the same thing with the polygon data here. So if we click on vector, data management, merge vector layers, and then in this window, we need to choose too many windows. Here we go. So we're going to choose the layers we want to merge. So we want the green space site data for SU and the green space site data for TQ. And hit run, and it'll create this green one called merged. So at the moment we can see green on the right and brown on the left. That's because it's underneath. If we move it up to the top, we should see all the green space data. And we're going to save this into our new geo package. So click browse and then Prac4, and then we're going to call this green space site. And there we go. And we could get rid of our intermediate data if we want, because we don't need those anymore. And we can actually get rid of all the point data as well, because we're not going to use that now. Let's get rid of those as well, just to be slightly tidier. So we're already working with our LA IMD pop count layer. We need to do a little bit of preparatory work in here. So at the moment, this is, if we look at the attribute table, here it is. We've got one row for each local authority. So for example, Swindon, and then we've got some IMD data. We've got our population. We've got our number of points, the number of green space access points, and green space access per pop. So one figure we're going to need later on is the area of the local authority. And so we need to add this now before we do the rest of the analysis. So if we turn editing on, we create a new column and we will call this LA area. And we want it to be a decimal number because we're going to have a decimal point in there. I'll pop us a new column in here. And we can use field calculator to add this for us. So we want to update an existing field, LA area. And in here, rather than under fields and values, which is where we normally go, we want to go this time under geometry. And so geometry here gives us access to all of the kind of spatial information that is stored behind the scenes. So we particularly want this one, $sign area. So this will return the area of the current feature. And so it gives us this number. So this is 2302.46544. And this is an area in square meters. And this is based on the coordinate system, which is British National Grid, that uses meters. So calculating stuff in square meters is a bit of a pain, just some very large numbers. So we're going to divide this by 10,000, and that will give us hectares instead. So, we've still got 23,000 hectares, but it's a much more manageable number. Let me choose OK, and we'll do that for all of the local authorities. And we're going to make use of this later, so we'll see this in a minute. So just turn editing off. You want to save, choose yes. Cool. So the next stage is to work on the green space site data. So at the moment, this is all of the green spaces that we've got. So we've got 33,000 of them. We're going to add a new column. So we're going to add a new column and we're going to call it green space. And it can stay as an integer. And this is going to be what we call a flag. So this is something to indicate later on whether an area is green space or not. So add a new column and then field calculator, update existing column, green space, and we're going to set all this to 1. So this will set every row in here to 1 because these are all green spaces. Turn off editing, save edits, and that's looking good. So now we're going to use the union tool. So this is where we combine different layers together. So for example, let's use, we go into processing and toolbox, and then we can type in union. And this opens the union tool. So what we're going to do here is we're going to set the input layer to our LA IMD pop count. So this is the local authorities. And then our overlay layer is going to be the green space sites. So it's going to combine these two layers, including our green space equals 1 flag that we had earlier and our local authority area. So we hit run. This will take a few seconds, so we just let that run for a few seconds. So often we end up waiting for GIS to do some processing, and that's fine. It's only going to be like 30 seconds. So take that time to take a deep breath and just relax a little bit rather than trying to do anything else. Cool. So that's done. Okay, my prediction of a few seconds was slightly off. It's 56 seconds, so call it a minute. Cool. So that's created this layer, this one called Union, this orange, massive orange one. So let's have a look to see what we actually have. So the spatial data, we have spatial units for every local authority and every green space area. So let's go into the attribute table, have a slightly more detailed look. So I'll just maximize this. So here we have local authority stuff first. So this is Swindon. And if we scroll across, we have the green space data. So we've got the function and the golf course. So we've got 12 Oaks Golf Course, St John the Baptist Church, Riverside Park, and so on and so on. So if we have a look, ooh, here we go. So Swindon, and then these are all the green spaces in Swindon. And then if we scroll down, we'll have other areas. So we've got Slough here, Brighton, Southampton, and so on. What we also have is, if I sort this by green space, so we have some areas that are where green space is null, and so these are areas that are not green space. So if we scroll over, we have one of these for every local authority. So this one is the area of Swindon that is not a green space. So that's highlighted now. Clicking on that highlights it. If I close this, we can see that on the map. Here we go, over here in Swindon. This is all of the area of Swindon that is not green space. Then all the other green spaces are separate rows in that data. So let's just clear that selection. That's cool. So this is fine. This is what we want. So we're going to save this as a layer called green space LAs. So right click, export, save features as, save it in our geo package, green space LAs, and hit OK. And let's get rid of the temporary layer. So this in itself, there's quite a lot of information in here, but we need to simplify it a bit. So we can use something called the dissolve tool. So what this does is this combines data, but we're going to combine it in a specific way. So we can say what fields do we want to combine? So what ones do we want it to be the same? So we're going to choose local authority. Let me check my notes, make sure I'm doing the right one. Yeah, local authority code. So we could use the code or the name, it doesn't matter. We just need one that's unique. So every local authority will be compressed down to one row. But also we want green space. So this was our flag. This was our green space flag. So where we say, is this green space or not? So what this is going to do is this will give us two rows for every local authority. One where green space is 1, all the bits of green space combined, and then one row where it is blank, where all the green spaces are not combined. Here we go, that's just running now. Cool. So let's have a look, see if we actually got what we're expecting. So yeah, so we got 2 entries for Kensington and Chelsea. And if we scroll across, one is green space and one is not green space. And then we should have this for every local authority. So if we sort it by local authority, Barking, Dagenham, Barnet, we've got 2 for everything. We've got this one row up here, and so this is green spaces that are not in any local authority. So these are the bits of green space that are in the gaps. So that's fine. Cool. So the default name for this was dissolved, and we're going to save this as something with a slightly more sensible name. So dissolve green space LAs. So the 2 data sets dissolve together. And so now we've got all this data, but we need to calculate the area. So we calculated our local authority area earlier. You might remember that in the first step. So now we're going to calculate the area for each total area of green space for each local authority. My apologies, I've missed a step. We're going to pull out the areas that are just green space at the moment. So we've gone into select by location, select features using an expression. So this is a great tool. This allows us to come up with some criteria. So here we're saying where green space equals, we're going to say 1. So this works in like the expression builder we've used already. So if you click all unique, it'll tell us what the different options are. So we just want 1 and choose select features and close. And we've selected here. So what we've selected is all of the areas that have green space. So we have 47. So we should have 47 separate local authorities. And these are the green space for each one. Remember that we have one row for each local authority. So even though our example in Swindon here, we've got lots of separate polygons. If we scroll down, okay, let's sort it by name. Here we go, Swindon. So we've got two entries for Swindon here. One is the green space, which is highlighted, and the other one is not green space. So even though we've got maybe, I don't know, 20 polygons here, it's all in one row. And this is what we call a multi-part polygon. Cool. So let's save that, export, save, and we just want the selected features. So choose the geo package, and we are going to save this as dissolve green space LA single. So now I click selected, you'll note this checkbox is also ticked. So this means we're just saving those selected features, and it's just added it as a brown layer, which is great. So now we're going to calculate the area. So this is the area just for the green spaces. We could add a column and do it that way, but there's a different way of doing it I want to show you. So in the field calculator, we can create a field and add to it in one move. So we just type the name in, choose what type, a decimal number, and then we can say what we want in it. So we're going to use the geometry again, and this time the area. So again, this is square meters, so we want to divide this by 10,000, just so we're working with the same unit. So it's hectares again. So here we go, we've got some numbers. That looks fairly sensible. Let's turn off editing and save that. So now we can calculate the percentage area. So we've got the green space area for each local authority, which is what we just calculated. And we had our local authority area, which we calculated at the beginning. So we can divide one by the other. So we will call this PC green space. It's best only to use letters in here, letters and numbers. You can't, the percent sign you might get away with, but it might be a bit flaky. So let's avoid that. And so what we're doing, so we're going to take the field manager. So we want the green space area, which is calculated, divided by the local authority area. And then that will give us a percentage, a decimal, 0 and 1, and we want it to be a percentage. So let's times it by 100, just to make it a bit easier to understand. Okay, and it should have done that. Here we go, percentage green space. And let's have a look at the values. So we've got 1, which is null, and that's the field the green space is outside. And then they vary from 1.9 for, which area is this? West Berkshire. All the way up to 44. 44 is Richmond upon Thames. 44 seems a little high, but it could be right. It could be reasonable. 20, 28, 24, 21 is more what we'd expect. Cool. So this will give us a nice output. In this, the way the data is set up at the moment, we're not really going to show a great map with it, but what we can do is do a nice graph. So we have the Plotly graph that we've added before. So let me just move that over here. Here we go. So a clean plot canvas, start from scratch. So we need the dissolve green space LA singles. And on the x-axis, we're going to say we want the percentage green space. And on the y-axis, we've got rank, average rank of deprivation. So let's have a look, see what that looks like. Cool. So we've got this outlier, Richmond upon Thames, which is very high, 40%. These are the other ones, which are a bit more typical. So we're seeing a similar relationship that we saw with the access points, but it's probably not quite as pronounced. So the areas with low rank of average rank of deprivation, so these are the deprived areas at the bottom, all of those have less green space generally, whereas the less deprived areas up the top here, 140 to 160, they have quite a range. So some of them are really low, but some of them are quite high. And then, slightly lower, they still tend to have more green space. It's not a hard and fast relationship. Clearly, there's obviously something else going on, but that could be all sorts of different things going on in there. So it's something worth investigating, worth having to think about what that might mean. So great. Thank you very much for taking part in this, watching this video. Please do have a go. Let me know how you get on in the comments, and please do subscribe for more videos on QGIS. Thanks.